Alright, this is example 4.3.3. It says a rock is thrown at 45 degrees and lands 5 seconds later. How far will the rock travel? So once again, we're going to be launching a projectile at some sort of angle. And that angle in this case is 45 degrees. Okay, and once we know that it lands 5 seconds later. So our given information here is we have that the flight time is 5.0 seconds. We have G is 9.8. And we were trying to figure out how far the rock will travel, which is the range. Because of that, we're actually going to have to use both equations. We're going to have to use R equals VI squared sine 2 theta over G to solve for the range. And we're going to have to use T equals 2 VI sine theta over G to solve for the initial velocity. So we also have the angle is 45 degrees. So we plug our numbers in and we say 5 equals 2 VI sine of 45 divided by G. So what we're going to do is we're going to isolate V, and how we're going to do that is we're going to multiply both sides by 9.8 over 2 sine 45. When we do that, it's going to cross out here, here, and here. And then I'm just going to have on the other side 5 times 9.8 divided by 2 divided by the sine of 45. When you have that, you get an initial velocity of 34.65 meters per second. Once you have the initial velocity, you can now plug it into the range equation and solve for the range. So we would say R equals 34.65 squared, that's the initial velocity going in there, sine of 90. The reason why it's sine of 90 is, remember in the original equation it's sine of 2 theta. Theta is 45 degrees, so 2 theta would be 90, divided by 9.8. So we do 34.65 squared times the sine of 90 divided by 9.8. When you do that, you get 122.5 meters.